Hello and welcome. Today we're going to go through the compressor section of the Synchrodyne Expand. So if you remember, the signal flow from the Synchrodyne is that the audio output from VCO1, which is the software VCO output, this output goes into a VCA and then to the first wave folder, and then from the wave folder into the filter, and then into a second wave folder. So that's kind of the signal flow for VCO1. If once you have the Synchrodyne Expand connected up, the compressor is inserted in between the first wave folder and the filter. So the signal flow now turns into VCO1 into the VCA, into the first wave folder, into the compressor, and then from the compressor back into the filter, and then into the second wave folder. So there are three controls for the compressor. One's the amount of compression, which is this knob, the attack, a decay, and also there's a toggle switch to set which output or input the compressor is listening to. So right at the top is the sidechain input. So if you insert a signal into here, we'll be listening to that, and then you can toggle it to listen to either the 2-pole or the 4-pole outputs of the Synchrodyne, of the filter of the first Synchrodyne circuit here. There is also a mixer which mixes the audio coming out from Synchrodyne and the Synchrodyne Expand before it gets into the Synchrodyne Expand, and let me explain that now. So I'll plug in the output from a compressor into my mixer, and if you turn this knob, which is the volume knob for the signal going into the VCA, so if nothing's plugged in here, then you'll be using the SAW output from VCO1. So I've turned that up. So that's just the SAW output from VCO1 going into the mixer and then to the compressor. The second input to the mixer is from VCO2 into the PLL and then into the compressor. So if I turn this knob up, so we're now listening to VCO2. There is also another external input to this. For this, I've got a kick drum that I created using the phase displacement oscillator, and if I plug this signal into this input 2 here, if I turn this knob up, you'll be listening to the external input, which is the kick drum. If I remove it, that's VCO2 and that's the kick drum. Okay, I think one of the interesting features of this compressor is there's a sidechain input, which you can use to sidechain the signal, which gives you that pumping sort of sound, which we'll look at right now. So what I have here is just a droning sound from VCO2. If I move the toggle switch up for a compressor to listen to the sidechain input, and if I plug in the audio with the kick drum into this input and turn up the compressor, you can hear this sort of ducking or pumping sound that it creates, and you can see with that LED when the compressor's switched on or off. So this knob here will determine how much compression or ducking it creates. So if I listen to this signal with the kick drum on, and back to the ducking sound. There is also this output here, compressor CV out. So basically it's a CV signal generated based on the compressor and how much its amount of compression it's doing. To listen to this, maybe we can plug this into the 1 volt per octave of VCO1, so you can hear what it's actually doing, what the compressor is actually doing. So if we bring in a kick drum, you just attack and decay. Okay, now I'd like to demonstrate the compressor listening to either the 2-pole or the 4-pole output. So if to switch the toggle in, toggle switch to either middle or bottom position, or let's try with the middle position then. This will be listening to this 2-pole output. There is a input to this filter here that you can plug in external signal to. If I actually plug in the kick signal that I have previously into that, and yes, you can hear the compression, the ducking sound. So it's actually listening to this 2-pole output. Let's try the 4-pole output. We'll try listening to the compressor CV out as well. Okay, if you maybe want to try listening to the 4-pole output, wave folder output. I'll put a random signal from the Walkabout into the 1 volt per octave of the VCO to animate the frequency cutoff of VCO1. You get some pretty interesting sounds. Okay, that's it for today. Hope you've enjoyed this, and see you next time.